Hi everyone, this is Mr. Moyo and welcome to another episode of MoyoMath. In today's session, we're going to be looking at Algebra Part 1. So we are going to basically look at first a simple definition as to what is algebra. So this is our first objective, and our second objective will be to look at simplifying algebraic expressions by addition and subtraction of algebraic terms. So before we get into it, don't forget to like, share and subscribe to my channel, to my YouTube channel. Persons who are interested in doing math and Add.Math lessons with me for the new academic year can call or WhatsApp me at a contact above 718-1104. So you can call or contact me at the number shown above 718-1104. So let's get into it. So to start off with our objectives, what is algebra? And of course, simplifying algebraic expressions by addition and subtraction of algebraic terms. So what is algebra? Algebra is the representation of arithmetic and other areas of mathematics in symbolic form. So symbolic form, we know with algebra, we normally use letters of the alphabet, letters from A all the way down to Z. So we use letters of the alphabet or we use other symbols. So once we bring those letters or we bring those symbols in mathematics, involved in the mathematics, then it's known as algebra. So for example, just to show how we can introduce algebra into our mathematics, the cost of 1 pen is equal to $3. The cost of 2 pens obviously will be to multiply 2 by $3 to give us $6. And this is where we can bring in symbols. Let's bring in a letter of the alphabet. The cost of X pens will be to multiply X by $3, which becomes $3X. Keeping in mind that X will represent any number of pens. So if you want to replace X with 5 pens, it's going to be 5 by $3, which is $15. If you want to replace X with 20 pens, it's going to be 20 by $3, which is $60. So X, which is our letter of the alphabet, which is our symbol, hence the introduction of algebra, can represent any number of pens in this case, this simple example. Now, when it comes to simplifying algebraic expressions, we need to understand what is a term. Now, a term is of the form ax to the power of n. A in your term is called the coefficient. X in your term is called your variable or unknown. N in your term is called your power or index. And just to show some simple examples of terms, if I have m is a term where 1 is understood in front of m, even though it's not seen as we clearly see here. 1 is known as your coefficient. Your variable is m, and a power of 1, if you have m as is, a power of 1 is understood as we see here, and that 1, it is called your power or index. If we have 3p squared, this is another term where the coefficient is understood to be 3. As we clearly see, p is your variable and 2 is your power or index. If we have 5, so numbers, positive numbers, negative numbers, 5 is a natural number or a positive integer, and 5 is also a term, but we call it a constant term. 5 can be expressed in the form ax to the power of n. So let's use the variable x for example. You can use any letter of the alphabet. Let's use x for example. 5 can be written as 5x to the power of 0, where x here is raised to a power of 0, which will indicate that this x to a power of 0. And when we get into indices later on, when I create a video on indices, you're going to see where any variable raised to a power of 0, it is always equal to 1. So we know 5, which is the same as 5x to the power of 0. Keeping in mind, x to the power of 0 is the same as 1. This is 5 by 1, which will give us 5. And therefore 5 is also a term, but known as a constant term. So we have here an algebraic expression. And we want to, this is part of our objective. to simplify algebraic expressions, and we need to understand what is an algebraic expression. So an algebraic expression consists of terms connected by an addition or subtraction sign, or both addition and subtraction signs. So examples of algebraic expressions, if we have 12p, now this is a term, but it's also an algebraic expression comprising of one term. This here is an algebraic expression, 5a minus 3b. We have 5a, which is one term. Of course, we have 3b, which is another term, and it's separated by a subtraction sign. So we have here an algebraic expression comprising of two terms. We have 7m squared plus 2n cubed. This is an algebraic expression comprising of 2 terms. We have 3x minus 8y minus 5x plus 10y. This is an algebraic expression comprising of 4 terms. So we want to learn how to simplify algebraic expressions. We're getting into simplification of algebraic expressions. So we want to simplify algebraic expressions by means of addition and subtraction. So for addition and subtraction of terms, we must follow some important rules. And the first and very important rule we must follow when it comes to addition and subtraction of terms is the fact that we can only add or subtract like terms. And what are like terms? Like terms are terms with the same variable and power. So for example, 3x plus 5x, this is an algebraic expression comprising of 2 terms, but these 2 terms are like terms because we have the same variables x, and each variable has the same power. One is understood by each, and therefore we can add the coefficients. 3 plus 5 will give us 8, and we maintain the variable and power, so we have 8x. If we have 8a minus 3a, we have like terms here because if we look, we have the variables a, same variable a, and each variable has the same power or index. So therefore these two terms are like terms, and what we can do is subtract the coefficients. 8 minus 3, 8 subtract 3 will give us 5, and we maintain the variable and power, so we get 5a. If we have 4p squared plus 2p squared minus 3p squared, all three are like terms because we have the same variables p and the same power, so p squared. So each term comprises of the variable and power p to the power of 2. And what we can do here is add our coefficients. 4 plus 2 is 6. And 6 minus 3 will give me 3, and I maintain my variable and power. So first very important rule when it comes to simplification of algebraic expressions through addition and subtraction of terms, we must ensure that our terms are like terms. And keep in mind, what are like terms? Just to reiterate, like terms are terms with the same variables and the same powers. And once we observe that, then we can add or subtract our terms. Now, we also need to understand some more important rules when it comes to addition and subtraction of terms. And we're looking at rules of signs of addition and subtraction. And what are these rules of signs? So for addition, we know if the signs are the same, we add the natural numbers. So natural numbers are counting numbers 1, 2, 3, 4, 5, straight to infinity. Those are natural numbers. So we add the natural numbers, and the common sign controls the result. So if I have negative 4m minus 9m, these are of course first like terms. We have the same variables and powers, but to simplify that to get our result, let's look at the coefficients. Negative 4 here is the coefficient of m, negative 9 is the coefficient of m. So if we have negative 4 minus 9, let's apply the rule. We have the what? Same signs. And once we have the same signs, we add the natural numbers. The natural numbers in this case will be 4 and 9. So we add them. 4 plus 9, which is 13. And we're going to keep the sign that is common to both. The sign common to both is that subtraction sign, which of course we place in front of our result 13, and we maintain the variable and power. So that m must be maintained as part of your results. We get negative 13m. If we have negative 3a squared minus 2a squared, first, these two terms are like terms, so once they are like terms, we can apply our rules of addition in this case. So we look at our signs next, and we clearly see our signs are the what? Same. So once the signs are the same, we're going to add the two natural numbers. 3 and 2 are your natural numbers. So we add 3 to 2, which will give you 5. And what are we going to do? The common sign, which is that negative sign, which is common to both, will control your results. We put that negative sign in front of your 5, so we get negative 5, but we must maintain the variable and power. So we get negative 5a squared. The rule of subtraction says if the signs are different, we subtract the natural numbers, and the sign of the larger natural number controls the result. So we have 2x squared minus 5x squared. These two terms are like terms. Clearly we have the same variable and power. So x squared, common to both, so therefore we have like terms, and therefore we can now apply our rules of signs. So we look at 2x squared, so that sign in front of 2 is positive. We look at our 5x squared, that sign in front of 5 is negative. So we have what? We have different signs. So once the signs are different, we're going to subtract the two natural numbers. So we're going to subtract 2 from 5, which is 3. And the latter part of this rule, which says the sign of the larger natural number is 5. And whatever sign controls the larger natural number will always control your result. So we're going to put that negative sign in front of our 3, but also we must maintain the variable and power, which is x squared. So we get negative 3x squared as our result. If we have negative 8pq plus 10pq, again we can simplify that because we clearly see we have what? Like terms. First and foremost, we have like terms, pq. So once we have like terms, we can apply now our rules of signs. So look at the signs. There's a negative sign in front of 8. There's a positive sign in front of 10. So the signs are different. So once they are different, what are we going to do? We're going to subtract the two natural numbers. So we're going to subtract 8 from 10, which is 2. And the latter part of the rule is very important. We are going to take the sign of the larger natural number. The larger natural number is 10. What sign controls it? A positive sign. So what sign will control your result? A positive sign will control your result. So therefore that positive sign will be placed in front of 2, which is understood. Positive sign is understood in front of 2. But remember, as part of your result, you must maintain the variable and power. So you get 2pq. So if you have some examples here, if we have to simplify the following algebraic expressions. So let's look at these examples quickly. So to simplify these expressions, so 1, we have negative 5x minus 8x plus 10x. So this here is an algebraic expression with 3 terms, and we can simplify because the first thing we recognize, we have a like terms. Each variable or each term has the same variable and power. All have the variable x and a power of 1 is understood. So work this out. Let's work out the first 2 terms and apply our rules of signs once we recognize they are like terms. So when the signs are what? The same, we add the 2 natural numbers. So 5 plus 8 is 13. And we're going to keep the sign that is common to both, which is that negative sign is common to both, so it will control your 13, but we are going to maintain the variable and power. So we have negative 13x. Of course, we're going to bring down our plus 10x, and let's simplify further. So we look at our signs, clearly they are like terms first. We look at our signs, we clearly see the signs are different. So once the signs are different, we're going to subtract the 2 natural numbers. The natural numbers, of course, will be 13 and 10. We subtract them. 10 from 13 will give us 3. And don't forget the latter part of the rule. the sign of the larger natural number. The larger natural number is 13. The sign that controls the larger natural number controls your result. So that will be placed in front of your 3, but we must maintain as part of our result the variable and power. So in simplifying that expression, we're going to get negative 3x. Let's look at the second example, 2. 13m subtract 16m plus 18m minus 22m. So we have 4 terms in this algebraic expression, and of course all 4 terms are like terms. We have the same variables and powers. So let's simplify. Normally when it's 4 terms, I like to do it in pairs. I like to work on the first 2, then I like to simplify the first 2, then simplify the last 2, and of course we simplify to get our final result. So 13m minus 16m. So we are going to simply look at our signs. Positive sign in front of 13, negative sign in front of 16. The signs are different. So when they are different, we subtract the 2 natural numbers. So 13 from 16 will give us 3. And the sign of the larger natural number is 16. The sign that controls the larger natural number controls your answer. And of course we maintain the variable and the power, so negative 3m. Plus 18m minus 22m, again, the signs are different. So when the signs are different, what do? We subtract the 2 natural numbers. So 18 from 22 will give us 4. And the sign of the larger natural number is 22. The subtraction sign or negative sign controls that 22, so that negative sign will control your 4. So we have negative 4, and what we do is maintain our variable and power. We can further simplify this expression. So again, we have like terms, first and foremost, then we look at the signs. So the signs are the what? Same. So when the signs are the same, what do? We add the 2 natural numbers. So 3 plus 4 is 7. And the common sign, which is that negative sign common to both, will control your 7, and we maintain the variable and power. So we have negative 7m. Let's look at 3. We have negative 5a squared plus 8a squared minus 15a squared. So we have an algebraic expression here with 1, 2, 3 terms. Let's simplify the first 2. So when the signs are different, we're going to subtract the 2 natural numbers. So 5 from 8 is 3. And the sign of the larger natural number is 8. A positive sign controls it, so that positive sign controls your 3. We don't have to put the positive sign, it's understood, but we must maintain the variable and power. Of course, we bring down negative 15a squared, and again, we apply our rules. So, when the signs are different, rules of signs, so when the signs are different, we subtract the 2 natural numbers. So 3 from 15 will give us 12. And the sign of the larger natural number is 15. A negative sign controls it. So a negative sign will control your 12, and you are going to maintain your variable and power. So negative 12a squared. So let's look at the last, which is 4. We have 15p minus 8p plus 3p minus 13p. Again, we have 4 terms. All 4 are like terms. So let's simplify. When I have 4 terms I like to, and all are like terms, I like to pair them up, work out the first 2, we work out the last 2, and then we further simplify to get our result. So 15p minus 8p, positive sign is understood in front of 15, negative sign in front of 8. The signs are different, so what do? We subtract the 2 natural numbers. 8 from 15 will give us 7. And the sign of the larger natural number controls your 7. We maintain the variable and power. Positive 3p minus 13p. Again, the signs are different, so what do? We subtract the 2 natural numbers. 3 from 13 is 10. and the sign of the larger natural number is 13. A negative sign controls it, so that negative sign controls your 10, and you maintain your variable and power. You can further simplify. Those two terms are like terms. So again, when the signs are different, and very important rules, when the signs are different, you subtract the two natural numbers. 7 from 10 is 3. And the sign of the larger natural number is 10. A negative sign controls that 10, so a negative sign controls your 3, and you maintain the variable and power. So you have negative 3p. So simplifying these algebraic expressions. Now, we can simplify algebraic expressions where we have different variables involved. So in this example here, we're seeing 4 terms in that algebraic expression, but 2 terms will have the variable a and power 1, 2 terms will have the variable b and power 1. So how do we simplify algebraic expressions with different terms? So to simplify, what we have to do is to 1. Rearrange the algebraic expression by grouping like terms. We're going to place like terms together, and then we're going to apply the rules of addition and subtraction. So let's look at this example here. So we have to simplify that algebraic expression shown. We have negative 6a minus 5b plus 8a minus 10b. So this is an algebraic expression with 4 terms, but if we look, 2 terms will have the variable a to the power of 1, 2 terms will have the variable b to the power of 1. So what we're going to do is rearrange by grouping or putting like terms together. So this will be negative 6a plus 8a, negative 5b minus 10b. So we rearrange by putting like terms together. And let's simplify. Rules. So clearly our terms are like terms involving a, power 1. Let's apply our rules of signs next. So when the signs are different, what do? We subtract the 2 natural numbers. So 6 from 8 is 2. And the sign of the larger natural number is 8. A positive sign controls it. So that positive sign controls your 2, and you maintain your variable and power. So we have 2. Negative 5b subtract 10b. So of course, like terms, each has variable b power 1. Look at our signs, so rules of signs implemented next. So when the signs are the same, we add the 2 natural numbers. 5 plus 10 is 15. And the common sign, which is that negative sign, will control your results. So we're going to put that negative sign in front of our 15, but we maintain the variable and power. At this point, nothing else can be done because those 2 terms are not like terms, and hence that remains as your answer. So let's look at some more examples. So let's look at those 4 examples. So we have here 1, negative 7p minus 5q plus 12p minus 3q. So we have 4 terms in that algebraic expression. So we're seeing 2 terms involving p, 2 terms involving q. So let's rearrange by grouping like terms. So negative 7p plus 12p minus 5q minus 3q. So we are looking at our terms involving p, which are like terms, same variables, same powers. So we are applying our rules of signs. So we look at the signs. So when the signs are different, what do? We subtract the 2 natural numbers. So 7 from 12 will give us 5. And the sign of the larger natural number is 12. A positive sign controls it, so that positive sign will control your 5. You don't have to put a positive sign because it's understood, but we must maintain our variable and power. So negative 5q minus 3q. Again, we look at our terms, which are like terms, same variables, same powers. So we look at our rules of signs, implement our rules of signs. So when the signs are the same, we add the two natural numbers. So 5 plus 3 will give us 8. And remember the latter part of the rule which says the common sign controls your result. So we're going to put that negative sign in front of your 8, but we must maintain the variable and power. So we have negative 8 cubed, and our final result will be 5p minus 8 cubed, and that remains your answer because those two terms are not like terms and nothing else can be done. So let's look at 2. We have negative 6n squared plus 8n minus 3n squared minus 5n. Of course, we have 4 terms in this algebraic expression. And if we look, 2 terms involve n squared, 2 terms involve n. So we're going to group those terms that are like terms by rearranging first. So this will be negative 6n squared minus 3n squared plus 8n minus 5n. And of course, to our terms that are like terms, we apply our rules of signs next. So let's look at those terms involving n squared. So, same signs, we add the two natural numbers, 6 plus 3 is 9, and the common signs above, which is the negative sign, will control your 9. And of course, we maintain our variable and power, so negative 9n squared. We look at our 2 terms involving n, 2 like terms. So again, we look at the signs to guide us. So, positive sign in front of 8, negative sign in front of 5. Signs are different, so we're going to subtract the 2 natural numbers. So subtract 5 from 8, which gives you 3. And the sign of the larger natural number is 8. A plus sign controls it, so that plus sign controls your 3, and you maintain your variable and power. So at this point, nothing else can be done, so therefore this remains as your answer because these 2 terms are not like terms, and therefore we cannot simplify any further. So let's move on to 3. We have 4h minus 3k minus 2 minus 9h plus 7k minus 10. So let's simplify this algebraic expression, which comprises of 1, 2, 3, 4, 5, 6 terms. And if we look, we have 2 terms involving h, we have 2 terms involving k, and we have 2 constant terms. So let's rearrange by grouping like terms. So this will be 4h, and again, it doesn't matter which one of the variables you place first in terms of the groups, it doesn't matter. So if you want to go with k first, no problem. If you want to go with h first, no problem. If you want to go with constants first, no problem. So this will be 4h minus 9h. This will be minus 3k plus 7k, and this will be negative 2, and we have negative 10, right? So we rearrange by putting like terms together, and let us simplify. So we have our like terms involving h to the power of 1. So we look at the signs next. Positive sign in front of 4, negative sign in front of your 9. So when the signs are different, we subtract the 2 natural numbers. So 4 from 9 is 5. And the sign of the larger natural number is 9. A negative sign controls it. So that negative sign controls your 5, and you maintain your variable and power. Negative 3k plus 7k. So again, like terms. So we look at our signs to guide us. So when the signs are different, we subtract the 2 natural numbers. 3 from 7 is 4. And the sign of the larger natural number is 7. A plus sign controls it. So that plus sign controls your 4. And of course, we maintain our variable and power. And negative 2 subtract 10, our 2 constant terms. So when the signs are the same, we add the 2 natural numbers. 2 plus 10 is 12. And the common sign to both, which is that negative sign, will control your result. Of course, this remains as your answer because all our terms are not like terms, and therefore we cannot simplify any further. So that remains your answer. So let's look at question 4, or example 4. We have here and I'll put example 4 here. So we have 6ab minus 4xy minus 7ab plus 9xy minus 3cd. So what we have here are how many terms? 1, 2, 3, 4, 5 terms, and yes, you can have terms with 2 variables, right? So these are 2 quantities. So we have 6ab, negative 4xy, negative 7ab plus 9xy minus 3cd. So we see terms which are like terms. We have 6ab and minus 7ab. So we group them together. We have negative 4xy and plus 9xy, which we group together. We have minus 3cd, which of course stands alone, so he will also be included as part of the rearrangement. So what are we going to do? Let's simplify. So we look at our terms which are like terms. So terms involving AB, we look at our signs. The signs are different. A plus sign in front of 6, a minus sign in front of 7. So we subtract the 2 natural numbers. 6 from 7 is 1. And the sign of the larger natural number is 7. A negative sign controls it, so that negative sign controls your 1, and we must maintain the variable and power. Variables in this case will be AB. So negative 1AB. Now if you have negative AB, that is also correct, because the negative 1 will be understood in front of AB. Now, negative 4xy plus 9xy, again like terms, so we look at our signs to guide us, so we know what we're going to do next. So, when the signs are different, we're going to subtract the 2 natural numbers. 4 from 9 is 5. And the sign of the larger natural number is 9, plus sign controls it, plus sign controls your 5, and we maintain our variables and power. In this case, it's going to be x and y. And of course, negative 3cd will stand alone, but also will be included as part of your results. You have negative 3cd. And at this point, nothing else can be done, so this remains as your answer. Yeah? So, looking at first simplifying algebraic expressions, I hope what was done here will bring some clarity to simplifying algebraic expressions. Don't forget to like, share and subscribe to my channel, and persons who are interested in my lessons, Math and Add.Math Lessons for the new academic year can contact me at 718-1104. Alright, so take care and I'll see you soon. Now the last slide has a special question, so I want us to pay close attention to this special question. I'm going to remove it from the screen now. So when I do my lives, I'm going to mention something about these special questions. So when you are given information regarding these special questions, you come back to this recording, you look at the question, and you use the question to help you to win a prize, right? So that's my hint. It's going to help you to win a prize. So make sure you join my lives so you can see what this special question is all about. Okay? So